All right, guys, if you took this version of the FRQ, so that means it says ABT1 Final Exam 2021, then you were on version 3, and that's the one we're going to be going over. So, very first one. Particle moves along the x-axis so that the velocity at time t is given by the following equation, where t is measured in seconds and v of t is measured in meters per second. Ensure all calculations have at least 3 decimal places. Great. So, very first thing is I'm just going to write like the general x of t, v of t, a of t, just so we're like, velocity is the derivative of position, acceleration is the derivative of velocity, and the double derivative of position. We'll be going over this more later, but just nice to keep in mind. Now, whenever I am given an expression or an equation like this, and I'm allowed to use a calculator, I do not want to have to go all the way through quotient rule if I have to. So I'm just going to take this and enter it into y1. So alpha y equals gets you that lovely stacked fraction, and that's just going to ensure that your order of operations are super clear. Remember, we're using x in lieu of t. And then that's all going to be over 10x cubed plus 3. I'm going to leave that in y1 for now, and because I'm looking for the acceleration, that means that I'm going to be looking at the derivative of velocity. So let's quit out of this, and I'm going to go to that Math 8, that in derive. And instead of retyping my function, I'm actually going to go to vars, y vars, and grab that function y1. So again, those steps were vars over to y vars. You're in that function menu and you're just entering y1 because that's where we stored that equation. We are evaluating at 2.3. So once I do that, I get that that value is going to be 0.514 when I round. We know that's meters per second squared, so I'm going to go over here and I'm going to say a sub t equals v prime of t. Therefore, a of 2.3 equals 0.514 meters per second squared. This was a 2-point question. You got 1 point for the correct value. So 1 point for value, and then 1 point for using your units correctly. So that was added 2 points total. Next one says find all values of t over the interval for which the speed of the particle is 1. So I'm going to recall what I know about speed. And I know that speed, I'm just going to call this s of t, is going to be the absolute value of velocity. I got a little funky with that parenthesis. There we go. Parenthesis, then absolute value sign. Which means that where s of t equals 1, v of t is positive or negative 1. So thinking about that from a graphical perspective, if you're looking at your function, right, you want to know where does it equal positive 1 and also where does it equal negative 1. And those are both going to be places where the speed of the particle is 1. So let's pull up that calculator. And here's where I'm really glad that I typed it in y equals. And if you didn't do that earlier, now is a good time to do that. I'm going to go over and go to my graph, but first let's do a little bit of manipulation with my window. I always go to that zoom 0 because that does that zoom fit. You can also do a zoom quadrant 1 if you want. Because this function's a little funky as well, I may go to my window and make a few adjustments. Let's do, 0 to 11 works great. Because I want positive or negative 1, let's make that y min a negative 3. Yeah. So I'm looking for the speed of the particles 1. It looks like there are no negative values, so I'm just going to go over here in y equals and type a 1 into that y2. And I'm going to treat this essentially like a system of equations. So it's looking like I have 2 solutions. So to get that, remember that's that second trace 5, enter, enter, enter. And that gets me my first solution is x equals 3.552. It's technically my second, so I'm just going to write it second over here. And then to get that first one, go back to that second trace 5, but I'm going to arrow over to make sure I'm telling my calculator to find that first intersection, because it just calculates that like intersection that's closest, right? So once I get that, I see that this guy is 0.7295, so 0.730. That was also 2 points, so you got 1 point for each of the answer. So 1 point for 0.730 seconds and 1 point for 3.552 seconds. So this was at a 2 as well. Is that if there is more than one time t exists where the particle is at rest over the interval, state the times and justify your answer. So remember, a particle is at rest when the velocity is equal to 0. So we can say v of t equals 0 at t equals. I know that it happens because I know that there are intersections on this graph. So I'm actually going to kind of like zoom in a little bit here. Oh my goodness, beautiful. And move that window to the right a little bit. Let's move it over to 4. And it looks like I have 2 solutions on that graph. So let's clear this out. I'm going to go over to that 0. And it wants us to kind of like hug almost the solution. So we're going to go to the left for this left justified solution that's going to be above the x-axis. Enter. To the right, or below the x-axis, and then there it is. That first time is 1.207. That other time, same thing, I'm going to go second trace 0. Because I'm grabbing this next solution, my first point is going to be that left bound is going to be below the axis. Then I'm going to go above the axis to get that right boundary. Again, like hugging that solution, and that is going to be 1.874. Give a quick zoom out just in case. Let's turn that let's do that x max to be 10 just to make sure that I am not missing any of those solutions. And I am not, there are only 2 and we are good to go. Same thing as earlier. You have 2 points on this guy, so 1 point would be the actual values themselves, and 1 point is the justification. So you knew that you were saying that this occurs when v of t equals 0. At time t equals 3 seconds, is the particle speeding up or slowing down, and justify your answer. So remember, for speeding up and slowing down, we're asking ourselves if it's speeding up, that means velocity and acceleration have same sign, and slowing down is opposite. So let's look at, we want v of 3 and we want a of 3. So again, I'm going to grab my calculator because that's going to be the most efficient way of doing this. And I'm going to go again to that second trace menu. It's kind of like has everything you need. And let's look at a value. So we're seeing like when x is 3, that's going to give us that velocity. We can also come over here and then just do the derivative because that's going to give us both that y value and that slope at that point. So if I press enter here, it's saying when x is 3, the derivative is positive, and so is my y value. So because both velocity and acceleration are positive, at t equals 3 seconds, the particle is speeding up. Because both velocity and acceleration are positive at t equals 3. So again, 2 points on this piece right here. You got 1 point for saying speeding up, and then another point for naming the justification or like the rationale. And it wasn't good enough to just say like they have the same sign, right? Because like, duh, you could have guessed like a 50-50, right? So you need to say that they're both positive or give the values for that. So both positive or give values. And then this point right here was for saying just like speeding up. So this was out of 2 as well. So the whole thing was out of 8 points. So kind of give yourself a little bit of a like, where was I at for that whole short answer? Number 2. We are looking for what is f of negative 2. Remember, for this piecewise function, no calculator. So piecewise function, we're just looking at like what piece of the domain, or sorry, looking at our domains and seeing like where does negative 2 fall. Because it's going to be in that first piece of the piecewise, I'm just going to say f of negative 2 equals 4. And that was all you had to do. That was 1 point. Is f of x continuous at x equals 0? So for x equals 0, we're looking at like where is 0, and 0 falls between these two piecewise functions, which means that I'm going to be looking at these separate two guys right here. So this 2x plus 4 and this x plus 4 over 4x plus 1. Remember that continuity is kind of like a multifaceted thing to look at because you have to say for a point or for a function to be continuous, it has to approach the value from the left and the right, same thing, and we have to be like filled in at that point, right? Because we can't just have a hole in the graph. So we have to say like we're approaching not only the same output, but we also don't have any sort of like point discontinuity occurring. So the mathematical way of saying that is the limit as x approaches 0 from the left equals the limit as x approaches 0 from the right, and the limit as x approaches 0 of f of x equals f of 0. Because both of these things give it that first limit statement, and then we also have to say that that also equals that there's like a value there. So let's get this done. The limit as x approaches 0 from the left of f of x, make sure you're saying naked, like we're not having the naked limits, right? Where that would just be that you're saying like, okay, what is the limit as x approaches 0 from the left? You're like, okay, of what? So we're saying of f of x, the function that's notated, and then I'm going to say this is going to be 2 times 0 plus 4 equals 4. The limit as x approaches 0 from the right of f of x, we're using that second function, is going to be a 0 plus 4 over 4 times 0 plus 1. It also equals 4. So the limit as x approaches 0 of f of x equals 4. And then we're also going to say what is f of 0? Well, 0 is included in that second domain. And so that also equals f of 0 because f of 0 equals 4. There were 3 points here. You got 1 point for showing each the left and right hand, and then 1 point for showing that value. The AP test would like to see the conclusion statements, but because we are just like still learning how this all works, we kind of broke out the points a little bit. So left, right hand limit, and then for actually finding that value and like saying that they're all equivalent to each other. Differentiability. So on this guy, for differentiability, remember that we have kind of like 2 parts. And part 1 is continuity. And then part 2 is the differentiability. So we're going to kind of like treat this in 2 separate sections. Continuity x equals 1. So we're looking at my bottom 2 pieces of this function. And I'm going to go ahead and just like write this down. Let's say f of x equals x plus 4 over 4x plus 1. And then x squared minus 2x plus 2. All right, now I know what I'm working with. So we have to prove continuity first. So remember again, same as before. When we're proving continuity, we need to be talking about the limits for both sides. So I'm going to say the limit as x approaches 1 from the left needs to equal the limit as x approaches 1 from the right. And it also needs to equal f of 1. So as I'm going here, limit as x approaches 1 from the left is going to be 1 plus 4 over 4 times 1 plus 1. So what, 5 over 5 is 1. The limit as x approaches 1 to the right is going to be that 1 squared minus 2 times 1 plus 2, which is also going to give us 1. And then f of 1 equals 1. So we're going to say the limit as x approaches 1 of f of x equals f of 1 equals 1. Therefore, yes, continuous. And this is something that like the more you do it, the faster you're going to get, right? So come over here, this was 1 point total. So as long as you did something about continuous, then that's 1 point. Now that it's continuous, remember if we would have gotten not continuous, we could have just stopped and said not continuous, therefore not differentiable, which is why we always check for continuity first. For differentiable, I'm going to say, all right, if there's f of x, f prime of x, and we're just taking the derivative, so quotient rule here, low d high minus high d low all over low low. And this is for the interval 0 to 1. Then you have a 2x minus 2 for everything greater than or equal to 1. So same thing for differentiability as like continuous in a way is that you need to show, and we'll go over this a little bit later about like what is the actual like proper AP definition. But for this test, we really wanted just to see that the limit as x approaches 1 from the left of f prime of x equals the limit as x approaches 1 to the right of f prime of x. We've already showed continuous, so we don't have to do that f prime of x situation there. We can if we want, right? It also needs to equal that. But we do know it is continuous at that point. So from the left, I'd be using that top function. So the limit as x approaches 1 from the left of f prime of x, we would be using this first function. So I would just be plugging in all those values. So that's a 4 times 1 plus 1 times 1 does nothing, minus 1 plus 4, 5 times 4 is 20, and then that's all going to be over 4 plus 1, so 5 squared over 25. The limit as x approaches 1, f prime of x from the right, a lot easier, right? 2 times 1 minus 2 is 0. And automatically, I see right here that this is going to be, those values are not going to equal each other. And remember, we don't have to write everything out. So I can just say like 5 minus 20 over 25 does not equal 0. These things do not equal each other. Therefore, we are not differentiable f of x at x equals 1. So, lot to unpack here. There were 4 points total, so 1 point was for that continuity statement, that first thing that you did. Second point was for going through and having your differentiable equations, right? So like you had your equations. You got another point for evaluating, so you knew that the values weren't equal to each other. And then you got another point for saying not differentiable. So this was 4 points total on this last part, which means that the whole problem again was out of 8 points. Give yourself an evaluation on how you did there. All right, last but not least, we have our related rates. A 10-meter ladder is leaning against a building. I always come in and like label these X, Y, Z. And because we're talking about rates, someone's pooling, I'm going to go ahead and just fill this in. dz over dt, that's the rate with regards to time. dx over dt, dy over dt. I know that this is a 10-meter ladder, so I'm going to fill this in for 10. I also know that that rate of the ladder is 0 because my ladder is not moving. It is not expanding or contracting, right? It is a ladder. It is staying stationary, or its length. Someone starts pulling the ladder away from the building. So the direction is going to be to the right. I always draw those arrows. So if I visualize that ladder being pulled away, I think about point A is going to be coming down. Starts sliding away from the building at a constant rate of 2 meters per second. That means that dx over dt is 2 meters per second. Find the rate at which the top of the ladder is moving towards the ground. So this is what we don't know. When B is 8 meters away from the building. So B is this x value, so that x is going to be 8. So if I look, I know that I'm going to be using an iteration of Pythagorean theorem. I need to know what y equals.
You could just use special right triangles here. You could use Pythagorean theorem if you needed to, but I know that this is an iteration of a 3, 4, 5, right? Because 4 times 2 is 8, 5 times 2 is 10, which means that this would be a 3 times 2, or 6. And I also know that I'm using that Pythagorean theorem and I'm differentiating with respect to time. Because none of these variables are t, we're going to use that implicit differentiation and have that like d whatever over dt for every single one of these. So this gives us 2x dx over dt plus 2y dy over dt equals 2z dz over dt. After that, you can get rid of the 2's if you want, right? But because this is an equivalent statement, right? Like both sides are technically being multiplied by 2, or you can leave them in. And then we're just going to be substituting. So I know that x is 8. I know that dx over dt is 2. It's positive because we're moving to the right, or we're like gaining distance, right? We're gaining value. I know that y is 6 because of Pythagorean theorem. I don't know what dy over dt is. I know that z is 10, and dz over dt, or the rate at which my ladder is expanding or contracting, is 0, which cancels that out. Solving, I get 16 equals negative 6 dy over dt, because I moved that over, divide by negative 6. It says round all answers to 3 decimal places. So when I come over here to my calculator, we would have negative 16 divided by 6. And that should be a negative 2.667. And that is in meters per second. It is negative because that ladder is sliding down the wall. So include units in your answer, and we are good to go. This guy was 4 points total. 1 point was for noting the equation you were using, so that's that Pythagorean theorem. 1 point was for solving for y. 1 point was for implicit differentiation. Right, so that's shown here and here. And then 1 point was for the answer. So give yourself points out of 4 on this last guy.